Hi, my name is Ruth Thirkill, and I will be presenting on using Biosonics multibeams to quantify California reservoir methane emission potential. First of all, why do we care about this? Well, climate change is increasing water temperatures and reducing water levels. But why is this important? Researchers are predicting that reservoirs will become large emitters of methane, and both of these issues contribute to increases in methane emissions. This is a really large problem because methane is 25% more capable of retaining heat than carbon dioxide, therefore making it a more potent greenhouse gas that will only increase the rate of global warming as it is released into the atmosphere. Bottom sediments of these aquatic systems are of particular interest because they are regions of intense microbial activity where the transformation of organic matter into methane can be exacerbated by higher water temperatures and lower water levels. Therefore, being able to quantify a reservoir's methane emission potential would be extremely helpful in predicting how these systems will respond to rising temperatures and how much these emissions could accelerate climate change. Our objectives. Back in 2015, Michael Anderson and Denise Martinez published a paper that evaluated the use of hydroacoustic measurements to remotely sense the methane content of superficial sediments in Southern California reservoirs. They did this by correlating it to point measurements of displaced gas volumes they took from within the sediments, as well as sediment properties they measured as well. Our objective is to reproduce what they did and link it to surface flux rates in order to get an estimate of the emission potential as a function of sediment properties. Our study sites are Chesebro, Lexington, and Uvis reservoirs, which are located in Santa Clara County, California. Using Chesebro Reservoir as an example, our first goal is to follow the blue line and conduct an acoustic survey of the reservoir sediments. As we move along the blue path, the Biosonics transmits a pulse that radiates out through the water column, and once it hits the sediment bottom, the pulse is then returned as an echo, and the magnitude of the return signal will give us information on the object that reflected the sound. There are two components to the return pulse: bottom hardness and bottom roughness. By breaking down the echo signal, we can take the ratio of these two pulse characteristics and determine the sediment type. We can then identify potential gas content by relating sediment types with measured methane concentrations from within sediment grab samples, which brings us to our next slide. In addition to our acoustic survey, we will also be collecting sediment grab samples and measuring surface emissions using floating gas chambers from various locations within each reservoir. The sediment samples will be analyzed for grain size, type, methane concentration, and organic matter, and the gas chambers will give us the flux rates, which we will use to estimate the potential methane output of each reservoir. So, just to sum everything up, our goal is to combine our acoustic survey data with the methane concentrations we will get from analyzing our sediment samples and connect them to our gas surface flux rates in order to make a contour map that will show the spatial distribution of methane gas present within lake bottom sediments that we will then use to estimate each lake's contribution to the global climate change. Our first appointment is next weekend, and we will repeat the process every quarter to see if there's a seasonal change in the methane content within the sediments and the flux rates emitted off the surface. Please wish us luck. We are really excited to be going out. Now I just want to take a few minutes to thank Valley Water for funding this project, Tahoe Environmental Research Center and LGR for donating their field equipment, Calms for their financial support, and Job, Matt, Mark, Holly, Alex, and Will for all of their field work and data collection assistance. If you have any questions, please feel free to contact me or any other member of my team. Thank you so much. I hope you all have a good rest of your day and a good rest of the conference.